Recurrent neural networks are powerful, aren't they? But as we discussed earlier, they have some big challenges, especially when it comes to remembering things over a long time. For example, imagine trying to remember the beginning of a long story while still keeping track of what's happening now. Recurrent neural networks struggle with that. So, how do we solve this? We use LSTMs, long short-term memory networks. If you haven't already watched my video on recurrent neural networks, I highly recommend you do so. It'll give you the background you need to really understand this. All right, let's dive into what makes LSTMs so special. LSTMs are built with computational blocks designed to control how information flows through the network. They have a unique ability to track information across many time steps, making them ideal for tasks like speech recognition, language modeling, and time series analysis. Think of an LSTM as a really smart memory box. Unlike RNNs, which only try to remember things for a short while, LSTMs can decide what to remember for the long term and what to forget. Similar to RNNs, LSTMs have a hidden state. This is short-term memory used for quick, on-the-spot decisions. But here's where LSTMs stand out. They introduce a new concept called the cell state. This is the long-term memory where they store important information for a long time. Together, they make LSTMs incredibly effective at understanding patterns and sequences, whether it's text, music, or even time series data. LSTMs have three main decision makers, which we call gates: forget gate, input gate, and output gate. These gates help the network decide what to forget, what to add, what to share as output. Let's break these down in simple terms. The forget gate's job is simple: decide whether to keep or throw away old information. For example, let's say you're learning a new language. You don't need to remember every word you've ever learned, just the ones that are relevant right now. The forget gate helps filter out unnecessary details. The forget gate uses a sigmoid function, which gives a number between 0 and 1. 0 means forget everything. 1 means keep everything. If the forget gate decides something isn't important, it sets it to 0. If it's valuable, it keeps it for later. The output of the forget gate is multiplied with the cell state from the previous time step. If the forget gate outputs 0, the old information is completely erased. If it outputs 1, the old information is retained. Next comes the input gate. Its job is to decide what new information to add to the cell state. Let's say you're reading a new chapter in a book. The input gate determines which parts of this new chapter are important enough to remember. The LSTM calculates this new information, n, based on the current input and the hidden state from the previous time step. It uses the tanh function, which scales the values between -1 and 1. Then, input gate uses the sigmoid function to decide how much of this new information is worth keeping. Finally, the filtered new information is added to the cell state. This ensures that only the most relevant details are remembered. The output gate is the final decision maker. Its job is to decide what information to share as output, the hidden state. Think of it like summarizing a story. You don't tell every detail, just the key points that matter. Here's how it works. First, the output gate uses the sigmoid function to decide how much of the updated cell state to reveal. Then, it combines this with the tanh function to produce the new hidden state. But there's one more step. The actual output of the current timestamp can be obtained by applying the softmax activation function on the hidden state. Softmax helps convert the hidden state into probabilities, making it especially useful when we need to predict categories or classes, like identifying words in a sentence or objects in an image. By combining these three gates, LSTMs can handle long-term dependencies much better than RNNs. They can remember what's important, forget what's not, and adapt to new information. Whether it's predicting stock prices, generating text, or recognizing speech, LSTMs are behind some of the smartest systems we use today. If you found this explanation helpful, don't forget to like this video and subscribe to the SmartSlides for more content like this.